Now we're going to move on to the chapter on prompts in LangChain. Now, prompts, they seem like a simple concept, and they are a simple concept, but there's actually quite a lot to them once you start diving into them. And they truly have been a very fundamental part of what has propelled us forwards from sort of pre-LLM times to the current LLM times. You have to think, until LLMs became widespread, the way to fine-tune a AI model or ML model back then was to get loads of data for your particular use case, spend a load of training your specific transformer or part of the transformer to essentially adapt it for that particular task. That could take a long time. Depending on the task, it could take you, months, or in some times, if it was a simpler task, it might take probably days, potentially weeks. Now, the interesting thing with LLMs is that rather than needing to go through this whole fine-tuning process to modify a model for one task over another task, rather than doing that, we just prompt it differently. We literally tell the model, hey, I want you to do this in this particular way. And that is that's a paradigm shift in what you're doing. It's so much faster. It's going to take you, a couple of minutes rather than days, weeks, or months. And LLMs are incredibly powerful when it comes to just generalizing to, across these many different tasks. So prompts, which control those instructions, are a fundamental part of that. Now, LangChain naturally has many functionalities around prompts, and we can build very dynamic prompting pipelines that modify the structure and content of what we're actually feeding into our LLM, depending on different variables, different inputs. And we'll see that in this chapter. So we're going to work through prompting within the scope of a RAG example. So let's start by just dissecting the various parts of a prompt that we might expect to see for a use case like RAG. So our typical prompt for RAG, or Retrieval Augmented Generation, will include rules for the LLM, and this is this you will see in most prompts, if not all. This part of the prompt sets up the behavior of the LLM. That is how it should be responding to user queries, what sort of personality it should be taking on, what it should be focusing on when it is responding, any particular rules or boundaries that we want to set. And really what we're trying to do here is just to simply provide as much information as possible to the LLM about what we're doing. We just want to give the LLM context as to the place that it finds itself in, because an LLM has no idea where it is. It takes in some information and spits out information. If the only information it receives is from the user's user query, it has it doesn't know the context. What is the application that it is within? What is its objective? What is its aim? What are the boundaries? All of this we need to just assume the LLM has absolutely no idea about, because it truly does not. So as much context as we can provide, but it's important that we don't overdo it. We see this all the time. People will over prompt an LLM. You want to be concise. You don't want fluff. And in general, every single part of your prompt, the more concise and less fluffy you can make it, the better. Now, those rules or instructions are typically in the system prompt of your LLM. Now, the second one is context, which is RAG specific. The context refers to some sort of external information that you are feeding into your LLM. We may have received this information from a web search, database query, or quite often in this case of RAG, it's a vector database. This external information that we provide is essentially the RA, retrieval augmentation, of RAG. We are augmenting the knowledge of our LLM, which the knowledge of our LLM is contained within the LLM model weights. We're augmenting that knowledge with some external knowledge. That's what we're doing here. Now, for chat LLMs, this context is typically placed within a conversational context within the user or assistant messages. And with more recent models, it can also be placed within tool messages as well. Then we have the question. It's pretty straightforward. This is the query from the user. This is, well, it's usually a user message, of course. There might be some additional formatting around this. You might add a little bit of extra context, or you might add some additional instructions if you find that your LLM sometimes veers off the rules that you've set within the system prompt. You might, append or prefix something here, but for the most part, it's probably just going to be the user's input. And finally, so these are all the inputs for our prompt. Here is going to be the output that we get, so the answer from the assistant. Again, I mean, that's not even specific to RAG, it's just what you would expect in a chat LLM or any LLM. And of course, that would be an assistant message. So putting all of that together in an actual prompt, so you can see everything we have here. So we have the rules for our prompt here, the instructions. We're just saying, okay, answer the question based on the context below. If you cannot answer the question using the information, answer with I don't know. Then we have some context here. Okay, in this scenario, that context that we're feeding in here, because it's the first message, we might be putting that into the system prompt, but that may also be turned around. Okay, if you for example have an agent, you might have your question up here before the context, and then that would be coming from a user message, and then this context would follow the question and be recognized as a tool message, and it would be fed in that way as well. Kind of depends on what sort of structure you're going for there, but you can do either. You can feed it into the system message if it's less conversational, whereas if it's more conversational, you might feed it in as a tool message. Okay, and then we have a user query, which is here, and then we'd have the AI answer. Okay, and obviously that would be generated here. Okay, so let's switch across to the code. We're in the LangChain course repo, notebooks 03 prompts. I'm just going to open this in Colab. Okay, let's scroll down and we'll start just by installing the prerequisites. Okay, so we just have the various libraries again. As I mentioned before, Langsmith is optional. You don't need to install it, but if you would like to see your traces and everything in Langsmith, then I would recommend doing that. And if you are using Langsmith, you will need to enter your API key here. Again, if you're not using Langsmith, you don't need to enter anything here. You just skip that cell. Okay, cool. And let's jump into the basic prompting then. So we're going to start with this prompt. Answer the user query based on the question below. So we're just structuring what we just saw in code. And we're going to be using the chat prompt template because generally speaking, we're using chat LLMs in most cases nowadays. So we have our chat prompt template, and that is going to contain a list of messages, system message to begin with, which is just going to contain this, and we're feeding in the context within that there. And we have our user query here. Okay, so we'll run this. And if we take a look here, we haven't specified what our input variables are, okay? But we can see that we have query and we have context up here, right? So we can see that, okay, these are the input variables. We just haven't explicitly defined them here. So let's just confirm with this that LangChain did pick those up, and we can see that it did. So it has context and query as our input variables for the prompt template that we just defined. Okay, so we can also see the structure of our templates. Let's have a look. Okay, so we can see that within messages here, we have a system message prompt template. The way that we define this, you can see here that we have from messages, and this will consume various different structures. So you can see here that it has from messages, it is a sequence of message-like representation. So we could pass in a system prompt template object and then a user prompt template object, or we can just use a tuple like this, and this actually defines, okay, this is system, this is a user, and you could also do assistant or tool messages and stuff here as well using the same structure. And then we can look in here, and of course that is being translated into the system message prompt template and human message prompt template, okay? We have our input variables in there, and we have the template too, okay? Now let's continue. We'll see here what I just said. So we're importing our system message prompt template and human message prompt template. And you can see we're using the same from messages method here, right? And you can see it's still sequence of message-like representation. It's just that, what that actually means, it can vary, right? So here we have system message prompt template, from template, prompt. Here, from template, query. There's various ways that you might want to do this. It just depends on how explicit you want to be. Generally speaking, I think for myself, I would prefer that we stick with the objects themselves and be explicit, but it is definitely a little harder to parse when you're reading this. So I understand why you might also prefer this. It's definitely cleaner, and it does look simpler. So it just depends, I suppose, on preference. Okay, so you can see again that this is exactly the same. Okay, with chat prompt template, and it contains this and this. Okay, you probably want to see the exact output. So it's messages. Okay, exactly the same as what I output before. Cool, so we have all of that. Let's see how we would invoke our LLM with these. We're going to be using 4.0 mini again. We do need our OpenAI API key, so enter that. And we'll just initialize our LLM. We are going with a low temperature here, so less randomness or less creativity. And in many cases, this is actually what I would be doing. The reason in this scenario that we're going with the low temperature is we're doing RAG. And if you remember before, if we scroll up a little bit here, our template says, answer the user's query based on the context below. If you cannot answer the question using the provided answer information, answer with I don't know, right? So just from reading that, we know that we want our LLM to be as truthful and accurate as possible. So a more creative LLM is going to struggle with that and is more likely to hallucinate. Whereas a low creativity or low temperature LLM will probably stick with the rules a little better. So again, it depends on your use case. If you're creative writing, you might want to go with a higher temperature there. But for things like RAG, where the information being output should be accurate and truthful, it's important, I think, that we keep temperature low. Okay, I talked about that a little bit here. So of course, a lower temperature of 0 makes the LLM's output more deterministic, which in theory should lead to less hallucination. Okay, so we're gonna go with LCell again here. This is, for those of you that use LangChain in the past, this is equivalent to an LLMChain object. So our prompt template is being fed into our LLM, okay? And from that, we have this pipeline. Now let's see how we would use that pipeline. So we're gonna get create some context here. So this is just some context around Aurelio AI. Mention that we built semantic routers, semantic chunkers, there's AI platform and development services. We mentioned, I think we specifically outline this later on in the example, so the LangChain experts, a little piece of information. Now, most LLMs would have not been trained on the recent internet. So the fact that this came in September 2024 is relatively recent. So a lot of LLMs out of the box, you wouldn't expect them to know that. So that is a good little bit of information to ask about. So we invoke, we have our query. So what do we do? And we have that context. Okay, so we're feeding that into that pipeline that we defined here. All right, so when we invoke that is automatically going to take query and context and actually feed it into our prompt template. Okay. If we want to, we can also be a little more explicit. So that you will probably see me doing this throughout the course, because I do like to be explicit with everything, to be honest. And you'll probably see me doing this. Okay, and this is doing the same thing. Well, you'll see it will in a moment. This is doing the exact same thing. Again, this is just an LSL thing. So all I'm doing in this scenario is I'm saying, okay, take from the dictionary query, and then also take from that input dictionary the context key. Okay, so this is doing the exact same thing. The reason that we might want to write this is mainly for clarity, to be honest, just to explicitly say, okay, these are the inputs, because otherwise we don't really have them in the code other than within our original prompts up here, which is not super clear. So I think it's usually a good idea to just be more explicit with these things. And of course, if you decide you're going to modify things a little bit, let's say you modify this to input down the line, you can still feed in the same input here. You're just you know mapping it between different keys essentially. Or if you would like to just modify that, I don't know, you need to lowercase it on the way in or something, you can do. So you have that. I'll just redefine that actually. And we'll invoke again. Okay, and we see that it does the exact same thing. Okay, so radio AI. So this is a AI message just generated by the LLM. Okay, expertise in building AI agents, several open source frameworks, router, AI platform. Okay, right. So provide development. So they have everything there, other than the LangChain expert thing. It didn't mention that, but we will. Yeah, we'll test it later on that. Okay, so on to few-shot prompting. This is a specific prompting technique. Now, many sort of state-of-the-art or SOTA LLMs are very good at instruction following. So you'll find that few-shot prompting is less common now than it used to be, at least for the sort of bigger, more state-of-the-art models. But when you start using smaller models, not really what we can use here, but let's say you're using a open source model like Llama 3 or Llama 2, which is much smaller, you will probably need to consider things like few-shot prompting. Although that being said, with OpenAI models, at least the current OpenAI models, this is not so important. Nonetheless, it can be useful. So the idea behind few-shot prompting is that you are providing a few examples to your LLM of how it should behave before you are actually going into the main part of the conversation. So let's see how that would look. So we create an example prompt. So we have our human and AI. So human input, AI response. So we're basically setting up, okay, with this type of input, you should provide this type of output. That's what we're doing here. And we're just going to provide some examples. Okay, so we have our input. Here's query 1. Here is the answer 1. All right, this is just, I just want to show you how it works. This is not what we'd actually feed into our LLM. Then, with both these examples and our example prompt, we'd feed both of these into LangChain's few-shot chat message prompt template. Okay, and well, you'll see what we get out of it. Okay, so we basically get, it formats everything and structures everything for us. Okay, and using this, of course, it depends on, let's say you see that your user is talking about a particular topic and you would like to guide your LLM to talk about that particular topic in a particular way. Right, so you could identify that the user is talking about that topic, either like a keyword match or a semantic similarity match. And based on that, you might want to modify these examples that you feed into your few-shot chat message prompt template. And then obviously that could be what you do for topic A. For topic B, you might have another set of examples that you feed into this. All this time, your example prompt is remaining the same, but you're just modifying the examples that are going in so that they're more relevant to whatever it is your user is actually talking about. So that can be useful. Now let's see an example of that. So when we are using a tiny LLM, its ability would be limited, although I think we're probably fine here. We're going to say, answer the user query based on the context below. always answer in markdown format, being very specific. This is our system prompt. Okay, that's nice. But what we've kind of said here is, okay, always answer in markdown format. It did do that. But when doing so, please provide headers, short summaries, and follow bullet points, then conclude. Okay, so you see this here. Okay, so we get this overview of already. You have this and this. It's actually quite good. But if we come down here, what I specifically want is to always follow this structure. All right, so we have the double header for the topic, summary, header, a couple of bullet points, and then I always want to follow this pattern where it's like to conclude. It's always bold. I want to be very specific on what I want, and to be fully honest with GPT-4o Mini, you can actually just prompt most of this in. But for the sake of the example, we're going to provide a few shot examples in our few shot prompt examples instead to get this. So we're going to provide one example here, second example here, and you'll see we're just following that same pattern. We're just setting up the pattern that the LLM should use. So we're going to set that up here. We have our main header, a little summary, some subheaders, bullet points, subheader, bullet points, subheader, bullet points to conclude, so on and so on. Same with this one here. Okay. And let's see what we got. Okay. So this is the structure of our new few shot prompt template. You can see what all of this looks like. Let's come down and we're basically going to insert that directly into our chat prompt template. So we have from messages, system prompt, user prompt, and then we have in there these. So let me actually show you very quickly. Right, so we just have this few shot chat to message prompt template, which will be fed into the middle here. Run that, and then feed all this back into our pipeline. Okay, and this will modify the structure so that we have that bold to conclude at the end here. Okay, we can see it nicely here. So we get a bit more of that, the exact structure that we were getting. Again, with GPT-4o models and many other OpenAI models, you don't really need to do this, but you will see it in other examples. We do have an example of this where we're using Llama, and we're using, I think, Llama 2, if I'm not wrong. And you can see that adding this few shot prompt template is actually a very good way of getting those smaller, less capable models to follow your instructions. So this is really, when you're working those smaller LLMs, this can be super useful. But even for SOTA models like GPT-4o, if you do find that you're struggling with the prompting, it's just not quite following exactly what you want it to do, this is a very good technique for actually getting it to follow a very strict structure or behavior. Okay, so moving on, we have chain of thought prompting. So this is a more common prompting technique that encourages the LM to think through its reasoning or its thoughts step by step. So it's a chain of thought. The idea behind this is that in math class, when you're a kid, the teachers would always push you to put down your working out, right? And there's multiple reasons for that. One of them is to get you to think, because they know in a lot of cases, actually, you're a kid and you're in a rush and you don't really care about this test. And they're just trying to get you to slow down a little bit and actually put down your reasoning. And that kind of forced you to think, oh, actually, I'm skipping a little bit in my head because I'm trying to just do everything up here. If I write it down, all of a sudden it's like, oh, actually, I need to actually do that slightly differently. You realize, okay, you're probably rushing a little bit. Now, I'm not saying an LLM is rushing, but it's a similar effect. By an LLM writing everything down, they tend to actually get things right more frequently. And at the same time, also similar to when you're a child and a teacher is reviewing your exam work, by having the LLM write down its reasoning, you as a human or engineer, you can see where the LLM went wrong if it did go wrong, which can be very useful when you're trying to diagnose problems. So with chain of thought, we should see less hallucinations and generally better performance. Now, to implement chain of thought in LangChain, there's no specific LangChain objects that do that. Instead, it's just prompting. Okay, so let's go down and just see how we might do that. Okay, so be a helpful assistant and answer the user's question. You must answer the question directly without any other text or explanation. Okay, so that's our no chain of thought system prompt. I will just note here, especially with OpenAI, again, this is one of those things where you'll see it more with the smaller models. Most LLMs are actually trained to use chain of thought prompting by default. So we're actually specifically telling it here, you must answer the question directly without any other text or explanation. Okay, so we're actually kind of reverse prompting it to not use chain of thought. Otherwise, by default, it actually will try and do that because it's been trained to. That's how relevant chain of thought is. Okay, so I'm going to say how many keystrokes I need to type in. Type the numbers from 1 to 500. Okay, we set up our LLMChain pipeline, and we're going to just invoke our query, and we'll see what we get. Total number of keystrokes needed to type the numbers from 1 to 500 is 1,511. The actual answers I've written here is 1,392. Without chain of thought, it's hallucinating. Okay, now let's go ahead and see, okay, with chain of thought prompting, what does it do? So be a helpful assistant and answer the user's question. To answer the question, you must list systematically and in precise detail all subproblems that are needed to be solved to answer the question. Solve each subproblem individually. You have to shout at the LLM sometimes to get them to listen, and in sequence. Finally, use everything you've worked through to provide a final answer. Okay, so we're forcing it to kind of go through the full prompt now. We can remove that. I'm not sure why it's there. So run that. Again, I don't know why we have context there. I'll remove that. And let's see. You can see straight away that's taking a lot longer to generate the output. That's because it's generating so many more tokens. So that's just one drawback of this, but let's see what we have. So to determine how many keystrokes to type those numbers, it's breaking it down into several subproblems. So count the number of digits from 1 to 9, 10 to 99, so on, and count the digits in number 500. Okay, interesting. So that's how it's breaking it up. Some more digits counted in the previous steps. So we go through total digits and we see that's, okay, 9 digits for those. For here, 180. For here, 1,200. And then, of course, 3 here. So it gets all those, it sums those digits and actually comes to the right answer. Okay, so that is, that's the difference with chain of thought versus without. So without it, we just get the wrong answer, basically guessing. With chain of thought, we get the right answer just by the LLM writing down its reasoning and breaking the problem down into multiple parts, which is, I found that super interesting that it does that. So that's pretty cool. Now I will just see, so as we mentioned before, most LLMs nowadays are actually trained to use chain of thought prompting by default. So let's just see if we don't mention anything, right? Be a helpful assistant and answer the user's question. So we're not telling it not to think through its reasoning, and we're not telling it to think through its reasoning. And let's just see what it does. Okay, so you can see, again, it's actually doing the exact same reasoning. Okay, it doesn't give us like the subproblems at the start, but it is going through and it's breaking everything apart. Okay, which is quite interesting. And we get the same correct answer. So the formatting here is slightly different. It's probably a little cleaner, actually, although I think, I don't know. Here we get a lot more information. So both are fine. And in this scenario, we actually do get the right answer as well. So you can see that chain of thought prompting has actually been quite literally trained into the model. And you'll see that with most, well, I think all state-of-the-art LLMs. Okay, cool. So that is our chapter on prompting. Again, we're focusing very much on a lot of the fundamentals of prompting there, and of course, tying that back to the actual objects and methods within LangChain. But for now, that's it for prompting, and we'll move on to the next chapter.